Make sure to like and subscribe right now. Yes, do it.
Hello, this is Ronit from MathX, and today we're going to be solving the AIME number 7 from the AIME II 2024. Now, this problem includes a bit of bashing out to acquire a solution, but in terms of the depth of thinking, it's not that too much. So without further ado, let's get started. Let n be the greatest 4-digit positive number with the property that whenever one of its digits is changed to 1, the resulting number is divisible by 7. Let q and r be the quotient and remainder respectively when n is divided by 1000. Find q plus r. Alright, so basically, the first thing we can do here is set up some cases here for the 4-digit number. So let's just first write out what n is going to be in terms of the constants a, b, c, and d. So to make that simpler, let's write n equals 1000 a plus 100 b plus 10 c plus 1 d. And that's just in terms of a, b, and c, and d being the constants that would be making up n. Now, since we know that whenever one of its digits will be changing to 1, the resulting number is divisible by 7. So I'm going to write the next few equations, and essentially these equations, just to clarify beforehand, I'm not going to be writing mod 7 on all of them, but just understand that they're all going to be meant to be divisible by 7, so I'll include that. Alright, so anytime it changes to 1, it'll be able to be divisible by 7 and it'll equal 0. So, for example, let's write first 1000. So 1000 plus 100b plus 10c plus d mod 7 is equal to 0. And that's a true statement because it's divisible by 0. Now, another thing we can write here is 1000a plus 100 plus 10c plus d mod 7 equals 0. Now I can do this again for c instead. So 1000a plus 100b plus 10 plus d mod 7 equals 0. And then finally the final statement of 1000a plus 100b plus 10c plus 1 mod 7 equals 0. Then next, we can actually divisible by 7 to get them into the lowest terms here. So when I say that, when you have 1000 divided by 7, what is going to be the remainder necessary? Because that's when you're using mod to simplify it. So let's just write them out for these equations respectively. Alright, so 1000 mod 7 is going to be equal to 6. So you can compute that. I kind of remember it. And for 100, it's pretty easy. That'd be basically 2. So 6 plus 2b, then plus 3c, then plus d equals 0. And I'm implying here that it's going to be mod 7. It may be a bit more confusing later on, so I'll include it after I'm finished writing these. So 6a plus 2 plus 3c plus d equals 0. Then 6a plus 2b plus 3 plus d equals 0. And 6a plus 2b plus 3c plus 1 equals 0. Now, using this information, you may see something pretty familiar, and I kind of see a systems of equations being set up here. So basically, using these systems of equations, we can use this to solve the problem. Alright, so basically, when we have these systems of equations simplified out, I'm not going to do all the simplification now, but trust me on this, if you're going to be doing the system of equations here, you'll be able to simplify it out to these four next equations. 3a minus b equals 2, then 2b minus 3c equals 6, then 3c minus d equals 2, then 6a minus d equals 5. And same as this is all given as mod 7. I'll probably write those on, attach it afterwards. Now the next thing we can do is now actually start to get the values for A, B, C, and D. And when we get that, it's going to be pretty easy because we're going to have our, essentially, basically our final answer given to us. Alright, so what we want to do here is that make sure we're going to be plugging in the correct values for A, B, C, D. So, similar to the other one, this is just going to be another systems of equations. Alright, so I'll just be solving it. I suggest you follow up along with me because these systems of equations prevalent throughout this problem. They take a little bit more time to do, but it's pretty clear thinking, so it's not that difficult. Alright, so basically, I have thought of the values for A, B, C, and D. Now, there's an issue when you're doing the values for A, B, and C, and D. And the issue is that when you're starting from the top, so if you try and get the largest one because you're trying to find the greatest 4-digit positive integer, an issue that prevails is that sometimes when you get a set of values, when you do mod 7 of it, that it'll actually have a value there. And it's not going to be actually fully divisible. Like when you swap it to 1, like whatever that term is, swap it to 1, it won't be divisible. So, the way we account for this, make sure we have our mod 7 implemented. And we still have to continue brute force. But luckily for you, that I already did the brute force on my end, so I already have some values for you. So I'll just be giving those. Sec. Alright, so you just have to do it based off the A value. You don't really need to worry about the other ones because you're going to be able to get those. So A, when you start off at 9 and then keep decreasing, you're going to find that 9 won't work, then 8 won't work, then 7 won't work, then 6 won't work, but 5 is a different story, 5 will work. So, the values that we have for us here today is that A will be equal to 5, and when you take the mod 7 for 15, you can get 1, but you actually don't want to get 1. You'll end at 8, and then 8 minus B, and B is going to be for equal to 6, so then you already have two values there, so let's just define them. A is going to be equal to 5, B is going to be equal to 6, now let's just do the rest of the values there. So 12, when you plug in B for your 2 there, so 12 minus 3C, C would have to be 4 in that case to get to 6. Because also note that all these numbers we know just from the general problem set here, they're not going to be like fractions or anything. So let's just write that down. So 4, not 4 actually, because when you're taking mod 7 of it, I meant to say, so 5694, the quotient for 1,000 going into 5694, that's just going to be 5, and then plus the remainder of 694 would equal our answer to be 699, and that is our final answer for this problem. So, 699. As you can see, we had a bit confusing bits in between, but that just comes from the casework present in this problem. But other than that, we had a pretty good solution, and glad to say that we are officially finished with this problem. So thank you for watching, and have a good day.